salicylic acid? Can anybody tell me?
Carboxylic acid.
Second?
Hydroxyl group also.
Yes.
Hydroxyl.
Hydroxyl group. And then third one? The
Is
middle
it
one?
Ester.
Phenol group.
Phenyl group. Yeah, you can say the phenyl. Yeah, phenyl group, or you can say the phenol if it includes the hydroxyl group, right? So the middle one is the benzene, right? Phenyl group and hydroxyl group and carboxylic acid, right? So these are the functional group. These are the main functional group in case of the salicylic acid. The second reactant is, what is the second reactant? Acetic anhydride, right?
Yes.
So what is acetic and why it is called the acetic anhydride? Why it is called the acetic anhydride? Do you know the acetic? What is the formula of acetic acid? What is acetic acid? Acetic acid, CH3COOH, right? So this is acetic acid, right?
Yes, doctor.
Yeah, so acetic acid. So from acetic acid, so two molecules of the acetic acid combine, and the water molecule is released from that. That is a condensation process, right? So as a result of this, acetic anhydride will form, right? So acetic anhydride is CH3CO, and then O is connected to CO and CH3. This is called the acetic anhydride. So meaning that the acetic anhydride is without water. Acetic acid without water is called the acetic anhydride. Understand?
Yes, doctor.
Yeah. So the two reactants, one is the salicylic acid, right, which is the carboxylic acid and the phenol, right? So I can say the aromatic ring with the phenol is called the salicylic acid react with acetic anhydride in the presence of. So what is on the arrow? Can anybody tell me what is on the arrow?
Sulfuric acid catalyst.
Sulfuric acid, right? Good. Sulfuric acid. So without sulfuric acid, the reaction will not occur, right? Without acetic acid, without sulfuric acid, a reaction will not occur, right? So what is the function of the sulfuric acid? Yeah, so what is the function of the sulfuric acid?
Catalyst, doctor.
Catalyst. So what do you mean by the catalyst?
Lowering the activation engine.
Reduce the activation energy.
Yeah. So
And speed up the
so meaning that this is just act as the enzyme in our body, right? It accelerates the reaction, right? It accelerates the reaction, right? So without catalyst, this reaction will not occur, right? So so can you all see my slide?
Yes.
Yeah. So now you will understand better, right? So I will go step by step. So so that will be easier for you. That how the synthesis of aspirin. Then I will let you know what are the important components of. So aspirin, right? So aspirin is also called the acetyl salicylic acid, right? Means it is a acetyl derivative of salicylic acid. So means that acetylation of salicylic occur, right? So you can say the aspirin is the acetyl derivative of the salicylic acid. So it will how this acetylation of salicylic acid occur, right? So this is the salicylic acid which contain carboxylic group. This is alcoholic group. This is phenyl group, or you can say this or this one, right? This one is the phenolic group, and this is the carboxylic acid, carboxylic group. It react with this acetic anhydride. So acetic anhydride, I told you that it is the condensation of the two acetic acid molecule. As a result, the water molecule is eliminated. So meaning that acetic anhydride is without water. So, so that's why it is called the acetic anhydride. So reaction will occur in the presence of acid. Acid can be the sulfuric acid, can be the phosphoric acid, right? So this is H means whether it is come from the sulfuric acid H NHSO4 minus, or first, or from the some cases there will be the phosphoric acid. So as a result of this, if let's say you can see in case of the salicylic acid, the most reacted one is the most nucleophilic is this hydroxyl group as compared to carboxylic hydroxyl group, because it is involved in conjugation. So in case of the this salicylic acid, this OH group is more nucleophilic. So that's why it will attack on this carbonyl group, and then it will acetylate it. So this is called the esterification, right? So this is the in the presence of this alcohol and carboxylic acid, the ester will form. So the aspirin, the reaction of the aspirin formation is called esterification. So you can see this this hydroxyl lone pair of oxygen will attack at the carbonyl group of the this acetic anhydride. As a result, this ester will form. So what is actually the mechanism? What is the purpose of this sulfuric acid? Sulfuric acid will initiate with first hydroxyl that's protonated with this oxygen, and then make this carbon more electrophilic. Then only this phenol will attack on this carbon. So you can see in the next slide, right? So in the next slide, you can see so in the next slide, you can see this is acetic anhydride. So this acetic anhydride first this protonated by this acid, right? This is the acid catalyst, which can be the sulfuric acid, can be the phosphoric acid. It protonated the oxygen of acetic anhydride, and then this how it is protonated, right? And then there will be the positive charge on oxygen. The electronegativity of the carbon is less than the oxygen. That's why the electron which is shared by the carbon and the oxygen will be pulled up by the oxygen. That's how the charge is transferred to the carbon. So that's how the carbon become more electrophilic, right? So now of this a lone pair of oxygen, right, which is the part of the salicylic acid, the phenolic group, the phenolic group or can say alcoholic group, which attack on the this electrophilic center of this acetic anhydride, right? So the OH of the salicylic acid is good nucleophile, but it is not as good as it can only this a single or individually can attack on the carbon. So that's why this carbon should be more electrophilic, so it can show that I need the electron or I am the electron deficient. So that's why so for this one, this acid where this acid catalyst will protonate this oxygen and make this carbon more electrophilic. So meaning that more electrophilic mean more reactive, right? So that make this hydroxyl group more more nucleophilic toward the carbon, and then this nucleophilic addition will occur, right? So later you will see that this reaction is total. This reaction is the nucleophilic substitution reaction. First nucleophile will add, right, and then what will happen in this one? This is the intermediate. So what will happen is the electrons between the carbon and the oxygen will shift here, right? And then the electron between the oxygen and hydrogen will shift here. It will form the double bond and it will be released as a acetic acid. So it will release as acetic acid, and this is the acetylation of salicylic will occur. So this is actually the reaction is nucleophilic substitution reaction. So this is called the esterification, the formation of ester. Have you understood what is the function of the acid and what is the reaction mechanism behind the formation of or synthesis of aspirin?
Yes, doctor.
Yeah. So this is the explained mechanism of this. Explain mechanism of the the acetylation of salicylic acid, right? So now you can see in case of the synthesis of this aspirin. So first they have add the acetic anhydride and the salicylic acid, and then after this they added the sulfuric acid on it. So sulfuric acid will accelerate the reaction and it form this aspirin, right? So as you see in this in the video, right, during the synthesis of aspirin, that this aspirin is generally this insoluble in cold water. Am I right? Hello.
Yes.
Yes, doctor.
Yeah, cold water, right? So as the reaction will occur, so you will see, you have seen that once the reaction has been done, the solution is clear solution, right? So once you will put into the cold environment or cold bath, right, ice bath, then the acid this acetyl salicylic acid or the aspirin will be crystallized out, right? If there is no cold environment, the aspirin will not crystallize out. So the cold bath is necessary because aspirin is insoluble in cold in the cold environment, right? So there are several methods to find out the yield of this aspirin, right? So one method of to find out how the aspirin will um, find out that how the aspirin will synthesize already, right? And how the synthesized aspirin, you can say that whether it is aspirin or not. There are several methods, right? You have seen in the video that one method is called the MP, this melting point, right? So the second one method is you have seen the IR, right, which is infrared. So I will explain later what is that technique is, right? So other technique can also be used in order to find out in order to confirm whether your product is aspirin or not, right? So this one is how the aspirin is formed, right? And this is this method in which the crystalline form of the aspirin will be separated by Buchner funnel. So this is the Buchner funnel. So here the pressure is created, and then there's a filter paper on it, right? So and then you pour this this aspirin, crystalline aspirin with solution, right, in it, and then it will be filtered out, right? So the excess also, and then it will be washed out with the excess of the water. So the question has been arises that why we wash the aspirin, why we wash the aspirin with excess of the water. So can anybody tell me? Hello. Hello guys. Yes.
What was the question again, Doctor?
Yeah. Question is, as you see in the this video, that aspirin is crystallized out in cold environment, right? Then you have to filter it by the Buchner funnel, and then we wash with excess of the water. So why we wash this aspirin with excess of the water?
To make sure that all the aspirin is filtered out.
Okay, and then if there is any excess of this salicylic acid or the acetic anhydride left on a crystal spec or crystals of aspirin, it will be also washed out. Understand? Because at the end you have to weigh only the pure aspirin, right? So we don't want any byproduct or any, because in the reaction you have seen the byproduct is acetic acid, right? So
Yes.
so we need only the aspirin, right? So if there
Yes.
any excess of the reactant left, which is the salicylic acid, acetic anhydride, and the acetic acid, we don't want that one. We only want the exact mass of aspirin. So in also so only this, so this is called the workout. Well, this is the where we do, at the end of the reaction we have to perform some workout. So in the workout that in this one in this practical we have they have used the water for the all the worked out of the reaction, right? Whatever the unreacted one, whatever the byproduct on the this product will be washed out through the excess of water. When we put the excess of water, it will be filter out all the whatever the particles of acetic acid or acetic anhydride or this salicylic acid on the crystal of the aspirin will be washed out. Have you understood that one? Clear that one?
Yes.
Yeah, so just
Yes.
so I'm just briefing you that what are the why this use, why the cold water, because in cold water generally the aspirin is insoluble, and then later you will see in hot water the aspirin will be dissolved in hot water, right? So this process is from here to from this formation of aspirin, and then aspirin will be crystallized out in the cold environment, and then we have, and then after that, that is the aspirin which is synthesized is being filtered out, and then on the top there will be the aspirin. This is called the crystallization process. So this one from aspirin, formation of aspirin till the filtration of this one. So in between that one is the cold water. We put in the cold, this flask on the cold water. That is the crystalline method, right? And then as a result of this Buchner funnel filtration, you will get the aspirin. This is called this aspirin formation and the crystallization process. But in order to purify the crystal, right? So the one more method is recrystallization. Recrystallization is called recrystallization method is generally is for the further purification of the crystal, right? So that is one of the method for purity. One of the method for the purity, that is called the recrystallization. So in the recrystallization method, generally, one can do is you can have the solid particle of aspirin which you got from the Bochner funnel, right? Filtration, and then you add the solvent on it, right? Solvent can be the ethanolic water or any solvent water which can solubilize. Okay, hot water can solubilize the aspirin, and this how the hot water it can solubilize the aspirin, right? And then after this it will put into the ice bath, it again crystallize, and then after this they pour the crystal this solution with the crystal on a Buchner funnel, and again you will filter out these crystals of aspirin. So meaning that the process where the yeah,
Doctor, sorry,
yeah, yeah.
doctor, your slide isn't showing.
Huh?
Your slide isn't presenting.
You are not able to see? Hello?
Yeah,
You are not able to see?
no.
Now I can see?
It's presenting, but it's small. I don't know.
Oh,
I
okay.
can see also.
Oh, very small, huh? Little.
So we can pin. We can pin.
Now can you can visualize? Still small?
Doctor, I think you should stop presenting and try present it again.
Oh, I can. Okay. Okay. Now, guys, okay?
Yes.
Yes,
Okay.
now
Okay.
okay.
Okay, thank you.
Yes.
Yes. So first I have explained you the how the aspirin synthesized. The second one, the aspirin has been crystallized out once you put the reaction solution into the cold water. So then the cold water aspirin will be crystallized out. So after the crystallization, then you have to separate the crystals of aspirin by the filtration by the Buchner funnel, right? First you put the filter paper on it and then filter it, right? And then pass the excess of the water from it, that is the reaction workout. So the reaction workout, whatever the end this waste product or byproducts or the unreacted reactants can or washed out on only or left on a filter paper is the aspirin, right? That is the crystallization as well as the separation of the crystal from rest of the solution, right? After that, if in order to see whether in order to purify further the crystals, right? So the method is used is called the recrystallization. Means you have to dissolve the solution, dissolve the aspirin again and recrystallize the aspirin again, and then after this you will filter out the aspirin. This is process is called the recrystallization. So in this one, so the crude, which is the crude solid is the aspirin. Aspirin is dissolved in a water or ethanolic solution. It will heat and it will be clear solution, right? Because aspirin is soluble in hot water or hot environment. So after that one, the aspirin, the solution will be cool out. You can put the excess of the water can, because in room temperature aspirin will be not soluble in the water, and then after this you will put the solution into the this ice bath. If the further the crystals of this aspirin will form, right? After that you will purify, you will again filter it this solution with the aspirin, crystal aspirin, by the help of Buchner funnel. So in the Buchner funnel, you have this filter paper, and then after this, this one is the crystal, right? So that's how the recrystallization of aspirin will occur, right? So one thing is before filtering this the filtering process, first you have to weigh the filter paper, empty filter paper, right? You have to weigh the empty filter paper, and then after this you have to put the filter paper on a Buchner funnel, then only you can filter it, because at the end we have to filter it, this filter the aspirin along with the filter paper, right? So you have to minus the weight of the filter paper, then you can get the actual mass of the aspirin. Is it okay?
Okay, doctor.
Yes. So now, this is how you can find out actually the synthesis as well as crystallization process, and the third one is recrystallization, right? Now the next step is you have to find out the yield, right? How much this aspirin is formed when you can have the salicylic acid. The amount of salicylic which you put is according to this video is about 2 point something, right? So how much by putting by taking the salicylic acid 2.0 gram, then how much salicylic this aspirin will form? That is the second process. So now we can see now you can see this calculation.
Yes, doctor.
Yes.
Yeah, so you have to understand this one very if not understand, then kindly let me know now, right? So now we are going to weigh or want to find out the percentage yield of the aspirin, right? So what the formula of this percentage yield is the the formula of the percentage yield is the, as you can see here, this one, right? So this one actual mass of this one is the actual mass of the aspirin. This is the theoretical mass of the aspirin, and then multiply by 100, then you can get the percentage yield of aspirin. So this one is actual mass, theoretical mass. Here this multiply by 100, right? In percentage you have to multiply by the 100. So here's 100 is missing here, right? Actual mass of aspirin and the theoretical mass of aspirin multiply by 100, then you can get. So first, how you can find out the actual mass of aspirin, actual mass, which is by the practical, from the practical. So in order to see the actual mass of this aspirin is your how much this salicylic has been taken is about the 2.027, right? And this is the filter paper mass, 0.354 gram, right? So and the aspirin and the filter paper mass is 2.711, right? So you have to subtract that one, this one, right? This filter paper, then you can get the actual mass of aspirin. Till here is okay? Hello?
Okay.
Yes,
Filter paper and the aspirin, right? After the recrystallization, right? This one is the total mass of the aspirin plus the filter paper. Then you have to subtract the filter paper mass, and then you can get the actual mass of aspirin. So this one you can, this one you can put it here, actual mass of aspirin. Now how to calculate the theoretical mass of the aspirin? So aspirin theoretical mass is calculated through through the equation, right? So first you have to calculate the moles of salicylic acid. So as you know, the formula to calculate the moles is gram divided by molecular weight. You can get the moles of salicylic acid, right? And this one is the mass of acetic anhydride, which is the which is come from the density, right? Because acetic anhydride we have taken in the form of liquid, right? So so you have to convert that liquid into the mass. So that's a density formula. Density is equal to mass upon volume, right? So that's how. So this is the density of the acetic anhydride. This is the ml, 5 ml we have taken this acetic anhydride, and this is the mass of the acetic anhydride, which is equal to 5 ml of this acetic anhydride. And this mass is divided by the molecular weight of acetic acid, the acetic anhydride. You will get the mole of the acetic anhydride. So now you have after calculating the moles of the salicylic acid as well as the acetic anhydride. So now you can see the equation, right? Equation is 1 mole of salicylic acid react with 1 mole of the acetic anhydride and form 1 mole of aspirin and 1 mole of acetic acid. Means the ratio between the salicylic acid and aspirin is 1:1, right? So 1:1, so means 0.147 moles of salicylic acid form the same moles of aspirin, which is 0.0147. Moles are equal. So meaning that here you can easily find out how many moles of aspirin will form when you will take the 2.027 gram of salicylic acid. Now you convert this mole into gram. So the same mass is equal to, you have mole multiplied by molecular weight of aspirin. This is molecular weight of aspirin. That's how you will convert the mass of aspirin into calculate the mass of aspirin from the moles of the aspirin. And the same, so this one is the theoretical mass. So that you will put on here, right? So actual mass is this one, 2.357 divided by the theoretical mass, which is 2.647, and then you have to multiply by the 100. Then you can get the percentage yield of aspirin. So meaning that the 2.072, if let's say the question has been arised, explain this one, that this all the procedure, that the conclusion, what is the conclusion of this calculation. So you can say that if the mass of salicylic acid has been taken is 2.027 gram, then 88.97% of aspirin will form. Understand?
Yes, doctor.
Yes, doctor.
Okay, right. So now I have covered the ones for the first step, which is the synthesis of aspirin. The second one, crystallize, how it crystallizes in the cold water. The third one is recrystallization for further purification of aspirin. And the last one, and the third for synthesis, crystallization, recrystallization. After this one, the how to find out the percentage yield. So these are the 4 steps, right? The last step is the how you can find out whether this product is aspirin. This is the most important thing, that after the any reaction or after the any product formation, you have any confirmation that, or any information test which can tell you that this product is the aspirin, right? So there are 2 different methods. There are several methods, but up to your level is only 2 methods, which number 1 is in order to find out the melting point, right? So the melting point is the easiest and the fastest method to find out whether your product is formed or not, right? So in order to find out the salicylic acid, this aspirin, generally the melting point range in case of a aspirin, if I am not a mistake, that I think so, it is 130 to 138, right? So this is the aspirin melting point, or generally the melting point of salicylic acid is, if I'm not wrong, maybe a 155 to 157, right? So you can see the shifting of the melting point. This is very evidence based answer, that the melting point of the reactant, which is the most prominent one, is the salicylic acid, is the melting point is 155 to 157, but the product melting point is 130 to 137, right? So the question arises, where the why the salicylic acid melting point is higher than the aspirin. Can anybody tell me? Hello. 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 Yes. Hello.
Yes, Doctor. Yes.
Yeah. So the question, my question is, why the salicylic acid melting point, salicylic acid melting point is 155 to 157, but the aspirin melting point is 135, 130 to 138. Why the aspirin melting point is lower than the salicylic acid?
I'm not sure, Doctor.
No problem, no problem. If you see, the answer is on the equation, right? If you see the salicylic acid, right? The salicylic acid consists of hydroxyl group and the carboxylic acid group, right? This one, right? So if you see the property of hydroxyl group, right? In just the example is water molecule. Water molecule has hydrogen bonding. Am I right?
Yes.
Yeah,
Yes.
so this is the answer, right? The molecules of salicylic acid, the molecule of salicylic acid are combined. They have intermolecular. They have the intermolecular attraction, right? So they interaction. So one salicylic acid make the hydrogen bond with the other molecule of the salicylic acid through hydrogen bonding. But right, so but this is not possible in case of aspirin, because aspirin has only one hydroxyl group, right? But in case of the salicylic acid, there will be two hydroxyl group, right? But hydroxyl group has a property to form the hydrogen bonding, right? Means intermolecular attraction between the salicylic acid. But in case of the aspirin, it is not possible because there is no free hydroxyl group, right? That's why. So generally, if the molecule have the property to form the hydrogen bonding, they have stronger bonding. So if they have the stronger bonding, so yeah, so you will need the excess of heat to break the hydrogen bond, right? Means the melting point of that substance will be increased, right? As compared to the molecule which have no property to form the hydrogen bonding, right? So that's why salicylic acid is have the intermolecular interaction. That's why salicylic acid has higher melting point as compared to the aspirin, which have 130 to 138 degree Celsius. On the answer is the bonding, hydrogen bonding interaction between the salicylic acid as compared to the aspirin. Got the answer?
Yes.
Yes. So just so the molecule which have the generally the molecule which have the property to form the hydrogen bonding, they have higher melting point as compared to the molecule which have weaker hydrogen bonding or which have no property to form the hydrogen bonding. They have less or low molecular, low melting point, right? So one method is melting point, right? The second method is here this the spectroscopy method, which is the infrared, right? With infrared, because this technique is the spectroscopic technique which tell us that what are the functional group present in a molecule. So this infrared technique tell us the information about the functional group. Means carboxylic acid means hydroxyl group means any aromatic ring. So this technique tell us. So this one have, you have to see this one wave number of the horizontal axis, and the transmittance is at the y-axis. So this is the band. This is the band. If there is any functional group is there, then the band will form. So every functional group has its own wave number. Means it has that functional group has its own property to show in the spectrum that I am there, right? So if you see, first I will can start from this salicylic acid. In the salicylic acid, the functional group more prominent is hydroxyl functional group, and the functional group carbonyl or carboxylic acid. Carbonyl, hydroxyl group, because hydroxyl group is here also here. So one functional group is hydroxyl, the second one is carbonyl, right? So this sharp peak tell us about the presence of hydroxyl group, and this sharp peak about 17 to 1800 is tell us the carbonyl bond of the carboxylic acid. But in case of aspirin, there will be no sharp peak of hydroxyl group, because there is no free hydroxyl group. Only one band of hydroxyl group is there, which is this one. Is because of this one. This is because of sharp peak is because of this hydroxyl group, and this peak is because of this hydroxyl group. So if you see in case of the cell, in case of aspirin, this one is just like little bit banded one, but this is present. We show the carboxylic acid is there, but the aspirin, but this salicylic acid hydroxyl group is being acetylated. So there will be no sharp peak of hydroxyl group, means the absence of hydroxyl group. It confirms that acetylation has been occurred, right? And then here is two peaks of carbonyl. It means one carbonyl because of this carboxylic acid. The second carbonyl is because the peak is this one. It's because of this acetyl carboxylic acid. So there will be two carbonyl peaks. This one two carbonyl peak, one in for only one hydroxyl group. But in case of this infrared, in case of the salicylic acid, one carbonyl peak, two hydroxyl peaks. One is this banded one, which is this one, and this carbonyl, this hydroxyl group is the sharp peak is here. So that's how one can find out whether the product is synthesized or not. Have you understood?
Yes, doctor.
Yes. So that's a question has been arises that how you can find out that if, let's say, if for example at the stage of the melting point, right? If the stage of the melting point, your melting point range is very high, means the reported one is 130 for 130 to 138 in case of aspirin, right? If let's say for example you have a melting point very higher, means 140 145, so what comes in your mind that what happened? that whether your product is wrong or what?
Yes.
It still has the impurities.
Yes. Yeah. So you have the impurities in it. So that's why the melting point is the quick. There's a this quick method. Quick method to find out whether the product is firm or the product is have some impurity. If the range, if the this aspirin is 100% pure, right, then the melting point range would be narrow, means 37 to 138. If little bit 99%, 98, then you have little bit broader range of the melting point 130 to 138. So this is the one of the method that one can find out whether your product is, how much your product is pure, by the melting point. So have you all hello?
Yes, Doctor.
Yeah, so have you all got this the information which I have provided you?
Yes.
Yeah, so
Yes.
the conclusion of this one, what I have explained you, is the first, the synthesis of the aspirin, right, from this salicylic acid and acetic anhydride in the presence of the sulfuric acid. Sulfuric acid acts as a catalyst, right? It makes the carbonyl group, the carbon of the carbonyl group of acetic anhydride become more electrophilic. So then only the nucleophile had the hydroxyl group of the this salicylic acid uh, will be attack on the electrophilic carbon, and as a result of the reaction, the aspirin will form along with the acetic acid, right? So this all the reaction will be occur under heat, right? So after that one, you will cool the system, and then you will put the flask or the reaction flask on a cold water, right? So aspirin is insoluble or not soluble in the cold environment, so it will start crystallize. And then after this, you have to separate out the crystals from the reaction mixture, right? So then you will filter it by help of the Buchner funnel, right? You have to place the filter paper on it, right? And then after that, you will put pour the reaction mixture, and you will separate the aspirin from the rest of the reaction mixture, right? And then you will pass out excess of the water. So then it is a workout, right? So cleanup process, right? So as a result of that one, the excess of unreacted material or any byproduct will be washed out from, or will which remain on the crystal will be washed out through this cleanup process, right? So this is called the crystallization and separate the crystals, right? And then after this crystalline process, crystallization, then you have to further purify the crystal by recrystallization process. So the recrystallization process is the process by which you can you can see pure the product more as compared to the crystal method. So crystallization method, you will dissolve the crystal on in the hot water, right? And then after this, you will cool down the system, and then after this, you will put into the cold water, right? Cold environment or ice bath, and then it will be further. Then it will accelerate. The cold water will accelerate the crystallization process of the aspirin, and then after this, you will first you have to weigh the filter paper, empty filter paper. Then you will put the empty filter paper on a Buchner funnel, right? And then you will filter it the crystal of this aspirin with the reaction mixture with the water, right? And then as a result of this, you will able to separate the recrystallized product of this aspirin, and then you will weigh uh, the aspirin with the filter paper, subtract the mass of the filter paper, right? And then you will get the actual mass of aspirin, right? So in the percentage yield of the yield formula, you will put the actual mass on the top. Bottom is your theoretical mass, right? Theoretical mass you will see. Through in theoretical mass is we will find out by how much more gram of this salicylic acid you have taken, right? From that you will find out how many moles of aspirin will form, and then you will convert that mole into gram, and then after that this gram that this will be your theoretical yield. Then you will put on the bottom theoretical yield and then multiply by 100. You will find out the percentage yield of the aspirin. And the last process, last thing is how to check whether your product is aspirin or not. So there will be several methods of the chromatographic method also, spectroscopic method also, right? But the quick method is, or the fast method is, as you can find out, you can check the melting point of the aspirin, right? So by using the MP apparatus, you can find out the melting point and compare the which is the melting point reported in case of the aspirin. If your range is wider, it means something impurity in the aspirin, right? So you have to, if there is an excess of, if there is an impurity, so there is a method you can recrystallize that aspirin again. So recrystallize the aspirin again, then you can solve this process. So this recrystallization process is the process of further purify the product, right? So at the stage of the MP, you can find out whether your aspirin melting point is exact, not exact. That's a very narrow region of melting point. That will confirm that your product is aspirin or not. In case of any product, any product formation, the MP is the fast method to find out whether your product is the right product or not, and whether your product is impure or your product is pure. The other method is, which has been you have shown in the explained in the video, is the infrared, which tell us the functionality, the different functional group is present in a product, right? Compare with the functional group present in a reactant, right? So in the reactant, you have the functional group is carboxylic acid and the hydroxyl group. But in the product, there is one carboxylic acid and one acetyl group, which is replace the hydroxyl group, right? So in case of this salicylic acid, you have the peak of the carbonyl, one peak of carbonyl and two peaks of hydroxyl group, right? But in case of aspirin, you have two peak of carbonyl group and one peak of hydroxyl group. That further confirm that your product is aspirin, right? So so this is how this practical has been conducted virtually. So yes, so can you tell me how much you have understood what I have explained? Hello guys.
Yes, doctor. Very
Yes.
clear, doctor.
Very clear everything, right? So I have explained you each and everything from whatever this technical thing, little bit about how the reaction mechanism occur, what is the function of the sulfuric acid, and then how you can find out in the percentage yield in the lab also. If let's say unfortunately we are in CMCO, right? But this is one of the method you can at least in the lab. If let's say, for example, you assume you assume that you are in the lab, right? So the same thing you have to done in the lab, right? So thus you have to weigh out the salicylic acid, and you have to put the 5 ml of acetic anhydride, and then you will put the some drops of sulfuric acid. Just you assume that you are in the lab, and you have the flask, and then you have put the salicylic acid from the weighing balance, right? And then you put the salicylic acid into the flask, and then you put the 5 ml, pour the 5 ml of acetic anhydride, and then you put the few drops of sulfuric acid, right? And then you put on a heating bath, right? So meaning 10 or 15 minutes you can boil it, and then after this you will cool down that one. Assume that you are in the lab, right? And then after this you have the ice bath. Means ice bath is nothing, just like same as ice in a tap, right? Or ice in a beaker, right? So you will put after cooling down the system, you will put your beaker into the this cold bath, right? Cold ice bath. So cold ice bath is not any just like any typical thing, right? It is only the system which provide the cooling environment, right? So so you will put in the flask of aspirin or you mixture into. So then it will accelerate the crystalline process of aspirin, because aspirin is not soluble in the cold water. So it will start crystalline, right? So salicylic acid start crystalline. So before crystallization, you will see that your solution is clear, your solution is transparent, right? So after putting into the cold water, then you will see it will become cloudy. It will become you see some of the crystal appearing into the start appearing into the flask when you put into the cold water, right? And then after this one, you will take out the flask from the cold ice bath, and then the Butner funnel is nothing, right? Butner funnel is one funnel. In the one side there is a pressure where vacuum is created, and the top is the funnel, which on the top of the funnel you put the filter paper on it, and then you start the vacuum function, right? You will function. Your function is vacuum is created, because of that vacuum it will start pump, or it will start the filtration on a vacuum environment, right? And then that's how you can get the crystals of this aspirin on the top of the filter paper. Then the second one is the recrystallization method. So in the recrystallization method, the one questions can we use the organic solvents such as ethanol to do the recrystallization method? Yeah, can, right? Ethanol also can use, cold water also can use, right? But logic is this one, right? Or ethanol, if the ethanol is used, ethanol can be used with the water. Why? Because on the crystallization process you have to heat up the system. So you can assume that if the organic solvent will be heat, then the chances of combustion will be increased. There will be the chances of flame, right? Because these solvents are flammable, right? So generally in our experience also, yes, people are can use the ethanol, but ethanolic water or an ethanol with the water, right? So ethanol ratio will be less as compared to the water. So it is less chance to be flammable, right? Or alternatively, you can use the water, heat through the heat this aspirin crystals in a hot water, right? So all the crystal will be dissolved in a hot water, right? And then after this you cool down the system, and then after this you put the system into the cold bath, and then recrystallization crystals of the aspirin will be occur, and then after this the you will filter it with the help of the Buchner funnel. Can you get my answer? Hello, hello guys. Yes.
Yes, doctor.
Yes. So yeah,
Yes, doctor.
the breaking hydrogen bond needed higher. Yeah. Of course, I have explained that the breaking hydrogen bond. Yes, of course. That's why you can see water boiling. I can say the water boiling point is higher than the other solvents, right? Which have no hydrogen bonding. That is a good example, right? The solvent or the compounds which have ability to form the hydrogen bond have the higher melting point or the boiling point, because we generally we need the high we need the higher energy or large or the higher heating environment in order to break the hydrogen bonding in case of the salicylic acid, right, as compared to the aspirin. Right. So yeah, so this is how just you can assume that you are today you are in the lab. We have tried to create the virtual lab in order to just you can assume that you are in the lab, right? So you can you watch this video, and then we we have tried our to explain that you are just because this is a simple experiment. You can easily can synthesize, crystallize, recrystallize. After this, do the MP or the spectroscopic method, and then you can find out the percentage yield, right? So, is it clear to all?
Clear, doctor.
Yes.
Yeah.
Clear.
So so your I already have taken your attendance because in the Excel sheet, and this lecture has already been recorded also. So later on I will, let's see what I will do, right? So so each and everything is explained. You understood each and everything,
Yes.
Yes.
right? So your lab report questions or lab report will be, I think, around 1 p.m. It will be out on a Google Classroom. So whatever I have told you in the explanation, the further you can read out and then search out. If let's say you have any question regarding this one, regarding this topic, the synthesis of aspirin. Yeah, one question come out. What is? In second video, why solution is not directly put into cold water after heating instead of adding cold water? Yeah, why the solution is not directly put into cold water heating instead of. You see, you see, this is the conceptual way, right? If let's say you have any flask which is come from the burning environment, right? Glass environment, right? So glass is heat, it's already have the heat, right? Not in the inside, outside. If you put that glass directly into the cold, it will break. Understand? So first you have to put the cold water or fly very eh, you start to putting the cold water or the room temperature or water or tap water slowly, then only it become the equilibrium between the hot water and the cold water, right? Meaning that you are slightly cooling down the system, then only you can put the flask into the cold water. If like, for example, you can do the simple experiment, right? So just your flask is already very hot, and the same hot flask you can put into the cold water, it will be break, right? So the alternatively, you can wait. Number one, you can wait till it will become into the room temperature, or you can start putting the cold water or tap water slowly. So it will, this system which has the very high entropy will be cool down, and then you can, if the flask is able to put into the cold water. Is it okay?
Okay, doctor.
Right, understand this, because it's a logic. What? Because the question is just come into my eyes, and this the what answer is come into mind is I already answered, right? Because if let's say you have any hot teacup also, any light glass teacup also, hot teacup, you can put into the cool. The chances of breaking that cup is more as compared to you can just cool down and then cool down, and then you can put into the cold water. Understand?
Yes.
Right. So, are you all happy? Are you all happy?
Yes, yes.
We're happy.
Yes,
Yes.
we're happy.
Yeah. So this one is my contact number, right? So so if you have any question, this one is my question. This, if you want to understand little bit of this, learn little, because I am the chemistry person. I am the chemistry man. Okay. So if you want to understand some chemistry, then so the question is what happen if we does not use a vacuum in experiment till yeah. So the experiment will not fail, right? No problem, experiment will not fail. But we want all the water to be sucked from the sucking from through the flask vacuum. So if you do, if you will do the normal filtration, for example, you have the funnel, right? You have the filter paper on it, and you start pouring. You start pouring the this solution onto it, right? What will happen? There will be some of the water molecule which will be stuck, or which will be on a filter paper, or filter paper will be not completely dry, right? Or some of the water molecule is stuck on the sulfur water molecule, or any other acetic anhydride or acetic acid will be on the top of the crystals, right? Or maybe excess of the water which you put onto during the Buchner funnel filtration, that will be not completely dry. Means the, if we say, yeah, because this is not your mistake, right? You are not in the lab, right? Buchner funnel is just like vacuum. You know vacuum cleaner,
Yes, yes.
right?
Yes,
Yeah,
yes.
the same example, if you mop, if you mop, right? If you mop your floor, right? Just usually I give the example of the daily life, right? For example, if you mop the simply mop the floor, or you can vacuum clean. So you vacuum clean, all the dust will be inside the vacuum. It means 100 is clear. It means you have more clean floor as compared to you will simple mop. Understand? So that is the same as if you provide the vacuum, it will be suck all the water, all the thing completely dry. So then only you can immediately can take out the filter paper, and then you can weigh out the filter paper along with the spring. If let's say for example, you will not use the vacuum pump, no problem, right? The vacuum pump is usually for the filtration, but vacuum pump is for 100 for sucking all the things, whatever the water content, all the things, or excess of the water which you put on the filter paper, that will be sucked out 100. So this for example, if you use the ordinary filter paper, it will also, but there is chance of increase of the mass of the aspirin, right? Aspirin, if your aspirin yield is very high, means 100 115 or 200 like this, it means something is stuck on aspirin. Your product is not only the aspirin, something along with the aspirin, or your filtration process, some maybe any handling, any handling reason, maybe any handling mistake in between, right? Maybe the reason for very high yield, right? Usually yield is up to 98%, 96%, 88% like this, because you have taken the 2.0 something salicylic acid, and the salicylic acid and the aspirin ratio is 1:1, right? So meaning that whatever the amount of the aspirin, salicylic acid you will take, little bit amount, little 98, 95% amount within the 100 region, 100%, there will be that will be your percentage yield of aspirin. Understand? If your aspirin is more than the salicylic acid, it will be the question mark. It will be meaning that there is something else except the aspirin. Understand?
Yeah.
That's very
Yes.
Right. So yeah. So if let's say you have any question, you can ask.
Doctor, the details about lab report will be posted on Google Classroom.
Yeah, Google Classroom. Yes, all the Google Classroom. If there's individual or if there's a group form, Dr. Sadia will announce in the once she will announce the lab report, she will, right? So just you can do a little bit homework. That's right. What I have explained you and how the practical will come. How actually practical has been conducted virtually, right? What are the components, what are the reactants and the products, why we use this crystal, why only the step is not stopped at, why the process not stop at the crystalline process, why we need the recrystallization process, right? Why the different method can be used, what is the quickest method in order to in order to find out whether your product is the the desired product or not, right? So these are all the things you have to keep in your mind. Is it okay? Clear everything?
Yes, doctor.
Yes,
Right.
crystal clear.
Yes,
So if everything is clear. So is there so any question? Any question? I have the 60 students in my classroom. So is there any questions? Any question? Any question, please? No question?
No, doctor.
No question? So can you permit me to exit the class? So
Doctor, there's one question.
Can we get
How about the lab report?
yeah lab report
Okay.
around 1 p.m. or maybe up today around 1 p.m. Dr. Sadia will announce the publish the lab report question or whatever, right? How you will conduct the lab report, whether individually, whether the this group form, she will announce. She is the RP and then the head of this practical, right? So she will give all the explanation, all the details regarding the lab report around. You have to wait a bit, right? Maybe half an hour, maybe 1 hour, right? So you will just keep in touch in your Google Classroom. So I will try this. Can we get this recorded class? Inshallah, I will try. This is my first time that I have recorded this one, right? So whether the recording is successful or not, I have to see. Understand? So don't worry, I will post it into the, if let's say if everything is okay, I will post it into the GC Google Classroom, no problem, right? So far everything okay. So can I exit the classroom?
Yes,
Sure,
doctor.
doctor.
Yes,
Okay.
yes, doctor.
Thank you. If you need any help or anything about the chemistry or about the pharmaceutical analysis chemistry, you are very much welcome. So I already give you the contact number, my contact number, so you can communicate with me at this.
Thank you, doctor.
Thank you. Assalamu alaikum.
Thank you,
Thank you,
doctor.
doctor.
Great.
Thank you, doctor.
Thank you.
Thank you, doctor.
Thank you, guys. Thank you.